some series to integral calculus. Some series to integral calculus, mind-blowing, historical, unprecedented discussion we have started. Can we will make unprecedented discussion in differential equations also. So that is also something that is mind-blowing. And I'm saying it. There are n number of ways. There are hundreds of ways that I would rather say hundreds of ways through which a differential equation, especially in the multivariable differential equation, can be solved. There be only one way? Okay, that's why these discussions are going on. Can there be only one way to solve a problem? How many ways a person would remember? And people generally, they tend to leave the mathematics. So many ways no one would calculate. Better to study something else. Okay, in that manner, we have started with summation, series summation. And in that, there is something called Fibonacci series. Fibonacci series is a very famous series among the computer programmers. So the people who do the computer programming, and they are at the beginning stage, among them Fibonacci series, typically it is very famous among them. What it says is that if I have a series of numbers, typically we identify any number through slot number. Slot number means slot number 1, slot number 2, or bin number. Someone can say bin number. Bin number 1, bin number 2, bin number 3, bin number 4, bin number 5, bin number 6, and so on. Okay, in the bin number 1, 2, or bin number 0, what the number we have? Bin number 1, what the number we have? We can also say slot number. So in the slot numbers, what number we have? So consider slot number is 0 and their number is 0. This is what generally written in a book. 0, 1, 1, 2, 3, 5, 8, 13, 21. This is called Fibonacci series. Okay, if I say in examination it is written 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. Can you compute summation of this Fibonacci series for if it is for n plus 1 terms, where the 0 is the first number, 1 is second number, 1 is third number, 2 is like so. Okay, now Fibonacci series is defined as, if I talk about slot number, at the slot number 0 number is 0, slot number 1 number is 1, slot number 2 number is 1 again, slot number 3 number is 2, and so on. In slot number x, what is the number? That number is summation of numbers in previous two slots. This is called Fibonacci series. Function over x, f, and in bracket x. Function over x equal to function over x minus 1 plus function over x minus 2, where x is the slot number. So function over x means number at slot number x. The number at slot number x equal to number at slot number x minus 1 plus number at slot number x minus 2. Okay, if I add two slots, previous two slots number, not slot number, the number that is in slot x minus 1, slot x minus 2, whatever number is there, if I add these two numbers, then it will become number for the slot number x. Slot number x minus 1, slot number x minus 2, whatever number they have, if I add these two numbers, that become number for the slot number x. X minus 1, x minus 2, x. What is the number for the slot number x plus 1? For x plus 1, it is summation of the number at slot number x and x minus 1. What is the number at slot number x plus 2? Summation of x plus 1 and x previous to. This is called Fibonacci series, and it starts with 0 and 1. The next will be 0 plus 1, 1. next will be 1 plus 1 2, next will be 1 plus 2 3. Okay, it leads to recursive call. If you see the mathematical programming, then it involves recursive call. What will be the next number, next number, next number? You have to keep on adding the previous two number. Okay, if a function takes the slot number, then if I say the calculate the number at slot number 10, then it will check. If slot number is 0, then return 0. If slot number is 1, then return 1. Or fx equal to fx minus 1 plus x minus 2, where f is function. Okay, if I say x equal to 10, then f10 equal to f9 plus f8, then it will go back as a recursive, and then 9 will be 8 plus 7, and so on, so that it will hit 0 and 1 slot, and at the end it will compute through the recursive stacking way in the typical function call. This is what is the programming. Anyway, now we are proceeding in a discussion. Can we compute summation? Can we compute summation of Fibonacci series? Summation means if I start with 1, consider, because now when I am going through summation, first term slot, that is slot number 0 and value is 0, does not make any sense. So if I talk about summation, then if I talk about the summation, then I can say I start with slot number 1, then up to n slot, what is the net summation? This is what discussion we are going through. I believe it is understandable and very much understandable. Okay, this is x-axis. Now, if I want to solve anything through calculus, then I have to come in the arena of calculus, the grammar of calculus, the environment of calculus, through which only we shall be able to make the actual calculation. For calculus, we need to have independent component and dependent component. No. You don't know. My calculus is 3-dimensional. If you have 3-dimensional, still there will be one independent and one dependent. How you can say there will be one dependent, one independent? I have x, y plane and z axis. Z axis is dependent upon x axis and y axis. There are 3 axes, not 2. Okay, calculus works in only 2, not 3. One independent and one dependent. Then your xy plane is independent component and z axis is dependent component. Z axis is one line that is dependent upon xy plane, that is one item. Okay, that way. So calculus works in dependent and independent. If I say dy by dx, then numerator y is dependent upon x. That's why people also write it dfx by dx, y equal to fx. Y is function over x. When it is function over x, means x will keep on changing. Accordingly, function over x will keep on changing. Means y will keep on changing if I change the x. If I change the y, then x may not change. X is not dependent upon y. Y is dependent upon x. I have 3-dimensional, then height. If I take a surface, and at surface we have different x comma y point. If I have different x comma y point, at different x comma y, I have different vertical, that is z. So height is dependent upon what is the x comma y. Means height is dependent upon xy plane. Okay, that is the concept behind the dependence. So whenever we tackle anything, if I say y dx or fx into dx, then we are trying to multiply two items. Fx is function over x into x. X is independent and function over x is dependent. We are multiplying two items. Dy by dx, dfx by dx, fx by x. We are trying to divide two functions, two items where denominator is independent and numerator is dependent. Fx into x, we are trying to multiply two items where function over x is dependent and it is dependent upon another item x. We are trying to multiply it. So whenever calculus comes into the picture, then dependence and independence. So whatever in examination, it is only written, I have a Fibonacci series 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. Compute the addition for the first n terms. N term. This is the in examination. Okay, what is n term and those things we will see. Now, if I want to solve it to calculus, then I have to rephrase the problem into the grammar of calculus. And calculus talks about independent component and dependent component. Consider this is x-axis. If this is x-axis, then this is considered as independent component. If this is independent component, then this is dependent component. Independent component, dependent component. If something like that, then I have along the x-axis, I have x value as slot number. X equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And x equal to 1, I have a vertical of 1. X equal to 2, I have a vertical of 1. X equal to 3, I have a vertical of 2, 3, 5, 8, and so on. If I connect all the top point of all the vertical, then it will draw a function. And this function we are calling it as fx. Okay, is there any fx? Yeah, fx equal to fx minus 1 plus fx minus 2. No, I don't want that. Is there any algebraic equation in fx? Yeah, someone has deduced it. And that algebraic equation is phi 1, right? Phi 1 to the power n minus phi 2 to the power n by square root of 5. What is phi 1? That is 1 plus square root of 5 by 2. What is phi 2? 1 minus square root of 5 by 2. Okay, then we try to solve it. Fx equal to phi 1 comes as 1.6 to the power n, or x. Fx equal to 1.6 to the power x minus, and in bracket, minus 0.6 to the power x whole to the power x. Divide by factorial of 5. Makes sense? Now we are seeing different behavior for even and odd. If it is odd number, then it is coming as phi 1 to the power x plus phi 2 to the power x. What is phi 2? Okay, our phi 2 is different. If I say phi 1 is 1.6 to the power x minus, and in bracket, minus 0.6 to the power full to the power x, then it will be minus 1 to the power x into 0.6 to the power x. Consider 0.6 as b and 1.6 as a. Makes sense? 1.6 as a and 0.6 as b, where 0.6 is square root of 5 minus 1 by 2. So it will become a to the power x minus 1 to the power x into b to the power x. Means when it is odd number, then power x will be minus plus a to the power x plus b to the power x by square root of 5. It is odd number. If it is even number, then it is a to the power x minus, because to the power x will become positive and minus, a to the power x minus b to the power x by square root of 5. Anyway, now the concept arising is, let's segregate even number and odd number. Odd number and even. This is odd numbers and this is even number. Odd number means I have x equal to 1, 3, 5, 7 and so on. Even number means I have x equal to 2, 4, 6 and so on. If I say function over x, for x equal to odd number, then it is a to the power x plus b to the power x by square root of 5, where a is 1 plus square root of 5 by 2, b is square root of 5 minus 1 by 2. Okay, if I talk about even numbers, then fx equal to a to the power x minus b to the power x by square root of 5. Next concept is, can I calculate the summation of all the odd number? If I try to calculate summation of odd number, means whatever function over x is x equal to 1, 3, 5, 7 and something like that, then we have to add all the vertical at x equal to 1, 3, 5, 7 and so on. Okay, if I try to calculate all the vertical, then we went through different methodology. One methodology is x equal to 1 and then next is x equal to 3. In that manner, I have a gap of 2, x equal to 1, x equal to 3. There is a gap of 2, 1 and 3, 2. If I take this area strip and go up, 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 till it hits a new continuous function called gx. Consider this is a continuous function called gx. Gx is a continuous function. If it hits gx, means this area which belongs to fx at x equal to 1, this is fx, discrete function. That is a to the power x plus a to the power x plus b to the power x by square root of 5 for odd number. For even number, a to the power x minus b to the power x by square root of 5. Okay, now if I have x equal to 1, then I have one area strip from 1 to 3 that go and hit gx. That goes and hit gx, and this area strip is same as the amount is same as the height what we are seeing at x equal to 1, left hand side. Okay, we tried it already. Anyone can watch our previous video. We have already tried this fundamental where if I say if I have any arbitrary x equal to x, any x equal to x, then function over x is a to the power x plus b to the power x by square root of 5 in odd number. That will be same as area from x equal to x plus 2. This area that go and hit gx means fx at x equal to x. That is the vertical at x equal to what you want. I want summation sigma. Summation x equal to 1 to n fx. Summation x equal to 1 to n fx equal to what it is. Equal to, now we have summation of, or if I have so many vertical line, against each line what is the area of gx, means summation x equal to 1 to n fx, where sampling is happening x equal to 1, 3, 5, 7 and so on. If sampling is happening in that manner, then we have now fx sigma x equal to 1 to n fx, means fx plus fx plus fx plus fx plus fx, where x equal to 1, 3, 5, 7, 9 and so on. That is equal to, we have for each vertical I have sub area. X equal to 1 to 3 gx dx plus 3 to 5 gx dx and so on. Last will be n to n plus 2 gx dx. This is what we have already calculated. If fx equal to x, then it will be a to the power x plus b to the power x by a square root of 5. That will be equal to limit x to x plus 2, x to x plus 2 gx dx. We solved it and we got gx. We got gx as logarithmic of a by a square minus 1 into a to the power x plus logarithmic of b by b square minus 1 b to the power x. This is what gx we got. Okay, if that is the case, then gx, if I calculate the integration of a to the power x, it will become a to the power x by logarithmic of a. They will cut down each other. At the end, the integration will be a to the power x by a square minus 1. This is what I remember. A square, I think so, yeah. A square minus 1. Okay, this is what I remember. A square minus 1. Because if I a to the power x, if I take x to x plus 2, it will be a to the power x plus 2 minus a to the power x. A to the power x, I take common factor a square minus 1. Perfect. Plus logarithmic of, a to the power x by a square minus 1 plus b to the power x by b square minus 1. This is what we got it. Okay, this is what we got it after integration. Then someone has to set the limit. Limit we started for the full computation. Limit we started with x equal to 1 to n plus 2. and we set it and we got the result. What about even number? What is your even number? Even number fx is a to the power x, a to the power x minus b to the power x by a square root of 5, where x is even number 2, 4, 6, 8 and so on. Make sense? Okay, if that is the case, then how I can find fx at x equal to limit x equal to x plus 2 gx dx. I have to find gx. Fx equal to gx dx, dx equal to dfx by dx. Okay, if fx is a to the power x, a to the power x minus b to the power x by a square root of 5. A square root of 5 for time being, just leave it. A to the power x minus b to the power x dx by dx. It will come as logarithmic of a to the power x minus logarithmic of b to the power x. Makes sense? Okay, this we will set as gx and we will try. Now a logarithmic of a to the power x minus logarithmic of b to the power x. If I do integration, then a to the power logarithmic of a and logarithmic of b will go away. It will come as a to the power x minus b to the power x. Limit will be x to x plus 2, because we are taking any x. At any x we have fx. This fx is same as x to x plus 2 gx dx. The area will be same as the left side vertical. Okay. Now we have a to the power x minus b to the power x as net integration limit x to x plus 2. That will come as a to the power x plus 2 minus a to the power x minus b to the power x plus 2 minus b to the power x. That will come as a to the power x in bracket a square minus 1 plus b to the power x in bracket b square minus 1. Okay. Wanted in a to the power x minus b to the power x. We are getting a to the power x into a square minus 1 minus b to the power x b square minus 1. This a square minus 1 b square minus 1 is extra. We will try again new gx. This is successive approximation. What is your new gx? We'll try new gx as log a by a square minus 1 a to the power x minus log b by b square minus 1 a to the power b to the power x. If we do integration and set x to x plus 2, then it will come perfectly alright. A to the power x minus b to the power x. This is what we want. So we have got the gx. Gx is log a by a to the power 2 minus 1 into log x minus b minus logarithmic of b by b square minus 1 at b to the power x. This is gx. Now to get the net computation, this is the most crucial step. 2, 4, 6, 8, n. Means it will start from 2 and then it will go to n plus 2. So we'll try now. 2 to n plus 2. Log a by a square minus 1 a to the power x minus log b by a b square minus 1 into b to the power x dx. If I do integration, log a and log b will go a square by a square a to the power x by a square minus 1 minus b to the power x by b square minus 1, and then limit x to x plus 2. If that is the case, then how it will be solved? Okay, it is 2 to n plus 2. Then it will become like a to the power n plus 2 minus a square. A to the power n plus 2 minus a square. Okay, then how much it will come? A to the power n plus 2 minus a square. I believe, leave it like that one. A to the power n plus 2 minus a square divided by a square minus 1. A square minus 1 minus b to the power n plus 2 minus b square divided by b square minus 1. This is what is the we are getting for the even number. We'll try even number. If x equal to 1, then Fibonacci is 1. When x equal to 2, Fibonacci is 1 again. When x equal to 3, Fibonacci is 2. When x equal to 4, Then Fibonacci is 3. Then 3 plus 1 will be 4. 1, 1, 2 and 3. 3 plus, if I take n equal to 4, then it will n equal to 4. Then it will come as 1 plus 3 as 4 only. Net summation is 4. We'll try here. We have now a to the power n plus 2 minus a square. A square I can take outside, in bracket it will become a to the power n minus 1 divided by a square minus 1. Makes sense? Okay. Plus b square in bracket b to the power n minus 1 by b to the b square minus 1. Makes sense? Okay. What is a? A is whole multiplied by 1 by a square root of 5 that we have left earlier. Anyway, now we'll try a is 1.6. 1.6 inside it is a to the power n. A to the power n. N is 4. 1.6 to the power 4 we had computed, I remember. 1.6 into 1.6 is 2.6. Into 1.6 is 4.2. Into 1.6 it will come around 6.9, I think so. 6.9 minus 1, 5.9. It will come as 5.9 multiplied by 2.6. 5.9 I can take as 6. 6 multiplied by 2.6. 6 multiplied by 2.6. How much it will come? 6 multiplied by 2.6 multiplied by 6. 6 multiplied by 2.6. 26 into 5. 26 into 6. 26 into 5 is 130. 26 into 6 is 156. So it will come as 156. Okay, it will come as 15.6. This will total term a to the power n plus 2 minus a square. A to the power n plus 2 minus a square, where n is 4, will come as 15.6. 15.6 divided by a square minus 1, that will come at 2.5, 2.6 minus 1, 1.6. 1.6. Okay, I think we could have done better. We did a square on top 1.6 into 1.6 divided by 2.6 minus 1, only 1.6 would remain there. Means we have to multiply 6 with 1. Oh, this is what we are doing. 6 into 1.6. That's it. That will come as 9.6. So 9.6 is the first term. 9.6 that I have to remember. Let's try another one. Minus. And then we have to try b to the power n plus 2 minus b square by b square minus 1. Okay, b square minus 1, b is 0.6. 0.6 square minus 1 will come around 0.36 minus 1. That will come as 0.64. It will come as minus 0.64. Minus 0.64. Numerator will come as b square. I can take outside. Here it is coming minus 64. B square is 0.6 into 0.6. 1 will go away. It will remain as minus 0.6. Minus is waiting outside. Plus 0.6. Plus 0.6. Inside we have b to the power 4 minus 1. B is 0.6. 0.6 into 0.6 is 0.36. Into 0.6, that will come around 0.2. Into 0.6, 0.12. 0.12 minus 1, that will come as around 0.9. 0.9 minus 0.9. Outside waiting is, I believe, outside waiting is 0.6. This is what I remember. 0.6. A square by down a square minus 1. 36 points, yeah, outside 0.6 is waiting. 0.6 into 0.9, that will come as 0.45 minus 0.6 into 0.45, something like that, minus 0.45. We have here 9.6. 9.6 minus 0.45 will come around 9.1, 9.2 or something like that. This is what I think. 9.2 divided by 2.2. Sorry, this side we have 9.1. 9.1 something minus 0.45 minus 9.2 minus 0.4, it will come around 8.8. 8.8 by a square root of 5, 2.2, that will come as 4. That will come as 4. What is the expectation one is? At location of 2 we have 1, at location of 3 we have 2, at location of 4 we have 3. 3 plus 1, 4. Perfect. Perfect. Okay. Now concept is that we have got this summation in odd and even now. Now we have to add both. What is the odd summation what we had got? Odd summation was a to the power n plus 1 minus a to the power 1. This is what I remember. A to the power n plus 1 minus a to the power 1 by a square minus 1 plus b to the power n plus 1 minus b to the power 1 by b square minus 1. This is what I remember for odd number. Plus, now I have to add for the even number. A to the power n plus 2 minus a square by a square minus 1 plus minus b to the power n plus 2 minus b square by b square minus 1. This whole we have to add. Will it work? Not. It will not work. Why it will not work? Because in odd number n is odd and even number n is even, and both are different. Now let's see the examination question. In examination it is written 0, 1, 1, 2, 3, 5, 8, 13, 21 up to n number. What is the total addition? If I take n number, then n will be positive or negative. That nth slot is positive or negative. Okay, that is the question. If now I will write, if n is odd number, if n is odd number, slot number odd, then we will rephrase our calculation. We will take n as the reference, odd n as reference, and even odd I'll subtract n minus 1. If n is 33, the last number is slot number 33, then even number will be 32. So we will rephrase what we did now. We did a to the power n plus 2 minus a square by a square minus 1 minus b to the power n plus 2 minus b square by b square minus 1. Here n I have to replace with n minus 1 because n in odd number we have taken as reference. Then it will become n minus 1. A to the power n minus 1 plus 2. It will become a to the power n plus 1 minus a square. Makes sense? A to the power n plus 1 minus a square divided by a square minus 1 minus b to the power n plus 1 minus b square divided by b square minus 1. Now it is simple. If I take odd number, it is a to the power n plus 1 minus a to the power 1 by a square minus 1. So a square will come as common factor 1 by a square minus 1, and there we can write as a to the power n plus 1 minus a to the power 1 plus a to the power n plus 1 minus a to the power 2. This will come as common factor. Now next is b to the power n plus 1 minus b. I can take b 1 by b square minus 1 as common factor. Then it will come as b to the power n plus 1 minus b to the power 1 minus b to the power n plus 1 plus b square. N plus 1, n plus will go away. B square minus b square minus b, whatever it is. So now it will come as total as 1 by square root of 5 into 1 by a square minus 1 into, in bracket, a to the power n plus 1 plus a to the power n plus 1. That will come at 2a to the power n plus 1 minus a to the power 1 minus a to the power 2, bracket close, plus 1 by a square root of 5 into 1 by b square minus 1 into, in bracket, b square minus b to the power 1, b square minus b. This is the exact result if n is odd. If n is even, then If n is even, then even n will be more than odd n. In that manner, we have to settle down both the computation. Either odd, where we had n plus 1, we will take n plus n as n minus 1 because it is less than even number. So it will become 1 by a, 1 by a square root of 5 into 1 by a square minus 1 into a to the power n plus 1, n minus 1 plus 1, a to the power n minus a to the power 1. Wherever n plus 1 is there, n will be replaced by n minus 1 and then merge it. That is the solution. Then anyone would see, okay, I don't have caliber to go to actually calculating the result, but this is how it is. Someone can try on pen and paper. We will try other methodology also at central area or left hand side area also. We will see if that result is easier than this result. This is not available in any of the book. Summation of Fourier series, summation of Fibonacci series through integral calculus. Anyone can try. Please don't mind supporting us, or please mind supporting us. +9 was the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.